Hey guys, welcome to Michelle's STEM Journey. I am Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2014, 10A, Problem 14, and it deals with triangles and graphs. I hope you all enjoy this video and let's get started. The problem states the y-intercepts P and Q of two perpendicular lines intersecting at the point A 6, 8 have a sum of 0. What is the area of triangle APQ? Okay, so I kind of sketched out the graph, and it's obviously not to scale, but it kind of gives you the idea of what the question looks like. I'm going to solve this problem using the algebraic way. And so we can let the two lines be y equals mx plus b, and the other would be y equals negative 1 over mx minus b. And this is because the two lines are perpendicular, so that means that the slope would be negative reciprocals, so it would be m and then negative 1 over m, and then we have b and negative b because it tells us that the sum of the y-intercepts is equal to 0. So it would give us b and negative b. So we see here that both of these lines contain the point A. And so we can plug the coordinates of point A into these two equations. And that would give us these two equations. And we see here that we have b and negative b, so we can just add these two equations up, and it would actually cancel out b. And now we can multiply both sides by m to get rid of the denominator. And now we can just simplify. Okay, so I factored this equation, and I factored it by using this. So I multiplied 3m and negative 3 and gave us negative 9m, and then 1 times m is m, and so negative 9m plus m would give us negative 8m. So there are many ways that you can factor, but this is just how I did it. And obviously it took some tries to figure out where the negative sign went. But in the end, we got this. And because if you multiply the multipliers, it gives us 0. So that means that one of the multipliers is equal to 0. Or it could be both. And so we got m equals 3 and then m equals negative 3. So you can choose either one of these to plug it in because they have the same effect. And so I'm just going to choose m equals 3 because that is easier to plug in. And I'm going to plug in into one of our original equations. So I'm just going to pick the first one because, again, it doesn't have a denominator. So here we see that after plugging it in, we got b equals negative 10. And so that means that according to this graph we drew here, the y-intercept of line Q would be negative 10. So let's just pretend that this point is negative 10. And so that means that the y-intercept for line P would also be 10. Because again, these two y-intercepts have a sum of 0. And so that lets us know that this whole line right here, line PQ, it is equal to 20 because 10 on this side and then 10 on this other side. So we already know the hypotenuse of triangle A, P, and Q. And now all we need to do is find the altitude of the hypotenuse. And that is very easy because we see that if you just draw a line right here, and so you draw the perpendicular line, and it would form a right angle right here. Then this line is equal to 6 because it reaches point A, and point A has an x-axis of 6. So that means that the altitude to the hypotenuse is equal to 6. And so all we need to do is solve it. So it would be 20, the base, times height, times 6. Or in this case, the hypotenuse times the altitude to the hypotenuse. And then you divide this by 2. And it would give us 60. So that means that the area of triangle A, P, and Q is D, 60.